Welcome to Earth Science, everybody. How we doing? I'm going to have you work a little bit on this latitude and longitude packet, but I'm not going to have you do the whole thing. So watch the video so that you see what you can get out of. And then I have another sheet also that you're going to look at that will maybe give you some shortcuts. But what we want to do is figure out the basic difference between latitude and longitude, which I think a lot of people are already going to be kind of comfortable with. If only I could go up and down on this document, it would make a world of difference. There we go. So check that out, read that. Those are your latitudes. Figure out the basic arrangement of the lines. They look different than longitudes do. Not only do they go a different direction, but the shape of the line themselves is different. I mean, if you look at this one right here, then I pop down, and there's some exercises you got to do that I don't think are too bad. You can see that these look different. These all come together up there at the North Pole. Lines of latitude never touch. They're all parallel lines. So I think this is all pretty workable. You'll find all of this stuff in the paragraph right above it. These are just giving me the latitudes. Don't forget north-south. But it says over here, north-south. Need those. Like A is at 80 degrees north. They give you pretty good examples for this. And then this is just how much separates them. The one trick down here will be that if one's in the north, you'll have to go down to the equator, and then how far do you got to go south? You know, if it's from 60 to 70 north, and that's easy, it's 10. If it's from 30 north to 30 south, then that'd be a difference of 60, you know? So you'll have to use your noggin a little bit there. But you're smart folks, you'll figure it out. This is all right from that paragraph. Not so bad. Just numbering by 15s on those, pretty easy, and then labeling. This one's cool. This is in what hemispheres. So like D is in the northern and the western hemisphere. We split the Earth into northern hemisphere, southern hemisphere over here, and then eastern, western over here, right? So tell me which is which. D is in the north and in the west. Do that for the others. Not so bad. So then it's like Battleship. You know, if you've ever played Battleship, it's what is the location of these. So I guess they didn't do one for you. So the little lightning bolt symbol would be at a latitude. I guess, I don't know. Does it matter which one you do first? I'll leave it up to you, I suppose, as long as you label it clearly. Latitude of 45 degrees north, longitude of 30 degrees west. So that's what you would put right in that box right there. And you can abbreviate like LAT, you know. All right, so now this is kind of deep in there. If I had my regular work computer, I'd rearrange these pages because I think this is probably the most important page. This is going to be how do we measure latitude? And it's one of these things that's like mind-blowingly simple if you've never heard this before. It's also one of these things that frustrates the daylights out of earth science teachers because it is that simple, but people will constantly make mistakes. Here it is. If you're this dude right here with a poor choice in hats, you look up at Polaris, you find that star, and however high in the sky you're looking, that's your latitude. That's it. So that's why this is in bold right here. Key idea. Well, that's a great circle right there. Your latitude equals the altitude of Polaris. That's it. So you're on a ship in the middle of the ocean. Like this was, I mean, explorers figured this out very early. You're on a ship in the middle of the ocean. If you can look up and find Polaris, however high in the sky you're looking, whatever that angle is, that's your latitude. It's that simple. So if you're sailing the ocean, you can always know exactly where you are north-south. Or if you're in the middle of nowhere, it doesn't matter. You can always figure that out by finding Polaris. How to find Polaris, if you've never done it, I don't anticipate this ever being on a test, but just for interest, you find the Big Dipper, and you follow the two ends, the end stars right there, and they go up to Polaris. Now the Big Dipper will, because the Earth is spinning, will rotate around Polaris throughout the course of the evening. So you got to find it and then point at those two. Polaris is always going to be right at the exact spot. I can point to it right now through my ceiling during the day. I know it's right there because it's at my latitude due north. Always directly above the North Pole. So if you're at the North Pole, you got to look straight up at 90 degrees to see it, and the latitude is 90 degrees. If you're where we live in New York, we're around 43, 44 degrees, depending on my house or up to school. So we look up at about 43 to 44 degrees to see Polaris to the north. Always there, always there, always there. So it's like, it's that simple, that obvious. So some of these questions will take you through that. Let me just pop over to the other guy here. Here's like a lot of the stuff from that document, but a concise, a pocket version of it, if you will. What latitudes look like, what longitudes look like. Now, I'm not going to, you check this out if like you're interested, but I'm not going to have you trying to figure out how to calculate your longitudes. It's tricky. It's not easy. In fact, and if this is at all interesting to you, I have a book out on the bookshelf out there about the history of maps. Early maps were dead accurate north-south, but then trying to go east-west was a nightmare. So they were terrible longitude-wise. This took, in fact, the ship that Darwin was on, the Beagle, when he sorted out evolution, that wasn't the purpose of that trip. That was to accurately try to measure longitude down around South America over to the Galapagos. He just happened to be on it and happened to figure that out along the way. Because it's hard. They had to bring all sorts of, essentially a clock, a chronometer. They had to bring a whole bunch of them that would be accurate as they made that whole entire trip, which wasn't easy. I mean, cell phones, watches, all of that, time's easy now, so we can figure it out. Heck, we can just use a GPS, right? But back then, unless you knew either your exact speed, which you don't if you're sailing in a big wooden ship, or exactly what time it is, which you don't unless you have extremely accurate chronometers, you're out of luck. Like as soon as you leave the sight of land, you don't know. So early maps were a mess east-west, but really accurate north-south. All right, that's enough rambling. So check this stuff out. You don't necessarily have to calculate your longitude, but check it out if you're interested. Back to the questions over here. Try these ones. This is going to be like, if you're getting how the North Star works, you'll figure it out. Now, I don't know where that city is, but it's at about 42 degrees north. So what's the altitude of Polaris? This has been like the last obvious one to give you. If you're at 42 degrees north, the altitude of Polaris is 42 degrees. That's how it works. Those two numbers are the same. So if they ever ask something like, I guess number 5, if the altitude of Polaris is 42, meaning the latitude is 42, well, what's altitude be tomorrow? 42. Those things are just going to stay. So what happens if you move north? Think about it. What happens to those numbers for latitude if you move north or move south? If those numbers for latitude are changing, then the angle of Polaris is also changing. What if you move due west, exactly west, without changing your latitude? You can figure that out. How does Polaris? Nope, it doesn't. That one I answered right above. Go back in the video about a couple minutes. If you can't see Polaris, if you can't find it, where did you end up on this planet? Hint, hint, we call it the North Star. If you're facing Polaris, that's a good one. What compass directions are you looking at? Here's where I'm going to say, cut it off. Right there. So I'd like you to make it to 12. The rest of the sheet, don't worry about it. All right. So that's going to be, if you're in a single period, that's probably going to be more than you got time for, but we'll roll this over into Thursday because Wednesday's off. Also, tomorrow's off. That's a good time to think about, okay, I got some time. I better give Finnerty some last minute labs here before he calculates grades for the grade book. It's a good idea. Sound good, folks? All right. I'll get those things posted. Good luck.